Welcome and thank you for joining us for our second webinar in our series, Integrating Dynamic Modeling and Simulation into Your Courses. If this is your first time, these webinars will be presented by experienced professors from various fields to highlight how they incorporate dynamic modeling and simulation into their courses. Our aim is to give interested professors a starting point or direction to begin to do the same. Today's is presented by Dr. Russell Richards and focuses on incorporating dynamic modeling and simulation into socio-ecological courses. But before we begin, let's go over some webinar mechanics. So if you are having any problems with your audio setup, they do have a section where you can check and make sure that you are not having any issues. And the really important part on this is we will have a questions chance at the end of this, so please type in your questions and we will ask them to our presenter. And now allow me to introduce today's presenter. Russell is currently a senior lecturer at the University of Queensland Business School in Australia. His research interest includes using dynamic modeling to understand and manage socio-ecological systems. He has used his expertise to develop decision-making tools that help with better management where humans derive benefits from coastal ecosystem services. We are very grateful to have Russell here today with us.
Thank you, Hilary, for that kind introduction, and welcome everyone. I'd like to thank you, Hilary, and IC Systems for organising these webinars and for inviting me to present this morning or this afternoon, wherever you are. I think it's a really good opportunity to provide these forums, not only to sort of share ideas, but to create or foster further networking amongst the system dynamics community. So I am Russell Richards. I am at the University of Queensland Business School, and this webinar is really an opportunity for me to talk about my experiences teaching system dynamics over the last 6 years, and teaching system dynamics to quite a diverse cohort of students, and reflecting on my ongoing attempts to engage with and make it more fun for the students. And so the thread for this webinar will basically follow me providing some contextual information about myself, some contextual information about the system dynamics course that I do teach at the University of Queensland. And then what I would really like to do is dovetail into the use of gamification and serious games, and how this can be used to leverage I guess more participatory, more dynamic interaction with the students. I'd also like to highlight that the system dynamics community does have a strong record of engagement in gamification already, the likes of En-ROADS and the Bear Game and Fish Banks, and I will be touching on some of those as I go through my presentation. Okay, so for the uninitiated, this is the University of Queensland located in Brisbane, in Australia. It is a sandstone university, and if you aren't aware yet, it is the host of the 2032 Olympic and Paralympic Games. That is Brisbane, not the University of Queensland, although the University of Queensland will be very much involved. As Hilary mentioned, I am a senior lecturer at the University of Queensland. I'm located within the UQ Business School, and I'm actually employed, my role is System Dynamics Lecturer. I teach a course called MGTS 7523 System Dynamics, and this year was the first time I've had the opportunity to actually present or teach system dynamics to industry through a program called Executive Education, which is very much about providing an avenue or forum to work with hands-on learning and collaboration with industry. My fields of research very much started off as an ecological modeler, ecological researcher, although my formal titles are in engineering. Very passionate about coastal systems, very much started in place looking at water quality, modeling water quality, linking that to coastal system health. So very much focused on the biota and the systems that are around, particularly places where people predominantly live, particularly in Australia. Also interested in fisheries. That really reflects my background as a hobbyist fisher myself, but also someone who's very passionate about maintaining the integrity of these systems. And then at a certain stage, about 10 years ago, I got pulled into, well, I say pulled in, I worked on a large World Bank project located in Indonesia and the Philippines that was focused on ecosystem services. And this is really my transition from an ecological systems person to a socio-ecological systems person, looking at the relationship between people and the environment, and that sort of mutual beneficiaries that we try to derive from that. I've also worked within tourism. Tourism is a part or important part of the UQ Business School, and so I get to engage there. Decarbonisation, really interesting to me, particularly the way that decarbonisation can be framed around the goal-seek modelling structure. Very interested in economic dynamics, and that was probably one of the main things that opened my eyes in terms of socio-ecological systems, how we can incorporate economic dynamics within our models. And then health modelling. Health has been within at least Queensland and Australia has been, and further afield than Queensland, but they've really embraced the use of system dynamics and systems thinking. In terms of modelling techniques, I am a modeller. I'm a bit of a data cruncher. I do systems thinking, but when it comes down to it, I would view myself as a system dynamics modeller, a numerical person. I'm also very interested in agent-based modeling, and then beyond process-based modeling, I'm interested in data type modeling, statistical modeling, regression modeling, Bayesian network, Bayesian inference. I've dabbled with machine learning, the use of neural networks, and I am very much positioning myself now to how do I use these, how do I add value through the use of serious games and gamification. Just to give a bit of an highlight as to some of the projects that I've worked on. So the purpose is really to highlight the diversity of where I've worked and applied my SD modeling skills, or helped to apply my SD modeling skills. A mixture of environment, tourism, and health. Okay, so it's a reasonably list. It's not the entire list, but it's some of the sort of the highlights. And I'd also like to highlight that these particular projects have been the focus of PhD students who have helped to advise, some through to completion, some are close to completion. But even then, you can highlight the diversity. You know, we can see work on high performance sports versus human-bat interactions, packaging waste, sustainability type issues, health issues. So I very much like the ability that I've been able to work. So these are often students who don't sit within the business school, but come from other disciplines across the university. And I think this also reflects when I'm teaching, my role is that I am often faced with students from different disciplines, different expectations, and what they hope to achieve or what they might gain from my course when I'm teaching it. So in terms of what system dynamics is about at UQ, it's this level course, and I really want to start with and it's only taught one semester a year, and that's the semester just gone. And I'd like to sort of acknowledge or a shout out to Dr. Carl Smith, who really was the person who set up system dynamics at UQ and was very much the centerpiece. And many attending this webinar will probably know of Carl. So Carl left UQ at the end of 2020, okay, and I hope to sort of carry on the legacy that Carl left in that regards. But it is a master's level course. It is very much focused around, I would say, simulation-based modeling of complex systems. The key word there would be the complex systems part of it. It's a 10-module course, split evenly between a qualitative focus and a quantitative focus. It draws heavily from John Sterman's Business Dynamics book from year 2000. It's also structured quite well, or aligned well with the systems approach, the idea of going through from problem articulation, dynamic hypothesis, then through to model development, testing, and scenario analysis. Okay, so module 1 to 5, qualitative, this is where we start to sort of introduce the philosophy of systems thinking, constructing causal loop diagrams. And then module 6 to 10 is a flip to a quantitative focus, where we start to develop stock and flow models and use these stock and flow models. Now, the delivery mode at University of Queensland is called a flipped course. And this is where there's online content delivery that's provided through a platform called UQ Extend, which is UQ's version of Edge site. And this is complemented by a weekly 2-hour in-class seminar workshop where we take on board the content and start to work on activities associated with that. The students I work with, so we can have up to 100, 150 students doing the course, very much a mixed cohort. Typically we'll see 50% who are enrolled in business degrees from management, entrepreneurship, finance, and so forth. We also get a lot of agribusiness students. We get a lot of health students, a smattering of environmental science, and some engineering. Okay, so already confronted with a diverse group and how to talk to those groups. If you compare, and so I'm in the privileged position that I've come through science and engineering. I now locate in a business school, and I know there is quite difference in the type of students I'm going to get through business versus the type of student I'm going to get through engineering. Engineering, a lot of focus on mathematics, and it's typically good for students when we come to the quantitative part. The business side, typically they are more engaged or more aligned with the qualitative focus. So then the challenge becomes, well, how do we bring everyone across all 10 modules from all these different areas? And the assessment, and I will touch on this again soon, but I do allow a certain level of autonomy or self-determination that the project topics are selected by the students themselves. This has implications for the amount of marking that needs to be done, but I also felt that this provides, I guess, an increased expectation or ownership of the students when they do their work within the course. And so just to capture some of the topics that the students have self-selected and worked upon, I've done a bit of a word cloud. You can sort of scan over those. The one that stood out to me a couple of years ago was a study on shark attacks in Australia. It seems a very Australian thing to do, but this is a really, really good insight, and particularly interesting that the person who did this subject wasn't a biologist or ecologist. They were someone from the business school, so they were able to apply the knowledge and to pick a passion project, basically. Now, the flipped delivery mode, which I've mentioned, was something that happened around the year 2019, where we changed from a traditional in-class delivery to a hybrid delivery. So previously it would be a 3-hour combined lecture workshop. We would present the content and then we'd do a workshop all in the same 3-hour block. But now it's this online self-paced content learning where we use the UQ Extend to deliver these sort of punchy videos, 5 to 12 minutes long, so bite-sized videos with the content, and we also package some additional information, some activities that they can download, and then we run the 2-hour workshop aligned to that. We still retain the 10 module structure with the 5 qualitative and 5 quantitative focus, and the activities that we use, so these are the ones that are available through the online part. Often cases from text, so we use the DuPont example from John Sturman's book. We use the New Zealand orange roughy fishery example, which is highlighted in Money and Kavana's text from 2007. And we also use something called UQ cases. Okay, so we're starting to edge our way towards the serious games part. The flipped course motivations were that we could scale the course. So if you've got this online self-learning content that people could access anywhere in the world, there's a potential to scale that course quickly. It also, the stars aligned somewhat because as we rolled it out, COVID-19 started, all the implications of mobility and work from home. And so that was, we were in a unique position that we'd already set up a course that was accessible during COVID-19. It was very much about self-paced learning, again, talking to this idea of self-determination and autonomy, and it's modular. So there are aspects that we could move around. But there are some sort of sides that have emerged that have been problematic. So even though it is a modular course, it is quite inflexible in terms of its content. And by that, I mean that we developed very professional looking videos for the video content. So to change or to particularly if you want to add new content, it requires a lot of resources to then go out and create new videos to the level, the same level that we have for the rest of the course. So that very much sets in stone in terms of what we've created, even that sort of transactional cost of change, like we've already invested this effort, do we want to lose what we have? I feel that while the sort of isolated learning or self-paced learning was a benefit, it also tended to create sort of individual approaches. And I feel that system dynamics works better when it's worked as a collaborative exercise, and that's very much a classroom experience. And then tech dependency, this is always going to be an issue, even like a webinar as this. If there's a few moving parts of technology, there's always something that can potentially go wrong. And a salient example for the work that I've been doing has been the UQ cases. We do always try to say, well, how do we try to overcome some of these problems in terms of when we were doing the online delivery through COVID. Actually found that the use of breakout rooms in Zoom was very effective. I've done other courses where the breakout rooms are a bit of a dead zone, but for system dynamics, particularly if you set it up as a group activity where you have someone who has to take leadership and share their screen using something like Stella Architect to create a causal loop diagram or stock and flow model, I found that it was really effective. It was very, very few instances where I went to a breakout room and nothing was happening. The choose your own adventure, I'll just skip that for the moment. I implemented a student-led drop-in session. This was very much when it was online delivery. We're now back in the classroom at UQ. But what I would do is I would start the lecture. So the lecture was, the 2-hour lecture was run online. And I would start 1 hour early and I would invite students to drop in. But the requirement was that the students had to lead the drop-in session. They had to come and ask questions. They couldn't come and just sort of wait for me to say something. And I found that was really effective and that really sort of added to the energy. And another follow-on, which started with the online and which I still implement in the classroom, is I start the class with a topic overview and a bit of a formative or informal quiz, just to get the sort of creative juices working. But a bit side that is then that if I'm providing an overview, I wonder whether there's some of the students aren't actually then feel like they need to see the course content, rather they would rely on that sort of summary. But a choose your own adventure has sort of 2 components. The first is allowing the students to select their own topic for the assessment. A few years ago, I would say the system dynamics was more focused on exams, and that was very much also aligned with trying to make it the scalability of the course. But some of the feedback from students found that the exam approach, or that sort of reliance on exams, was a little bit flat in terms of their expectations. And so I took a leap of faith a couple of years ago for this choose your own adventure, knowing full well that it would be quite a requirement for my marking, but that worked well. Hand in hand with that is the UQ cases, which I'm about to start talking about. So this is now, we're going to move from teaching system dynamics at the University of Queensland to highlighting our attempts to use games and gamification. And the way I'll walk through this is through what I call the UQ cases evolution, which started in 2018, 2019. So myself and Carl Smith, we attended a bit of a workshop at the University of Queensland about the Harvard cases, these paper-based cases, and both being modelers and both being dreamers. We came out of that meeting thinking, oh, we could do really good stuff with simulation models. We developed these models, these stock and flow models, so we could turn them into some sort of game to be used in teaching. Sort of another serendipitous moment was we went to the System Dynamics Society conference in Delft in, I think it was 2016, and we met Ninad Jagdish, who's the director of BTN, a Singaporean tech studio, and Ninad had a monitor showing some software that looked very much like Unity 3D, which is a gaming software, and I recognized it because I had been using it myself. And so we went and talked to Ninad, and from that, over a period of time, we worked out that we could not only create these games, but we could make them look like a game. We could make them look like something else that doesn't necessarily look like a technical type of thing, but something that might be more engaging with students who are more of the digital, I guess, generation. We were able to obtain funding for the UQ Cases project. We put forward a proposal to the School of Business, and the School of Public Health at the University of Queensland also chipped in, and we got funding to create these simulation model games. And we held a public call within UQ for expressions of interest for case topics. And that then led us, so along the top there are 3 of the games that were developed. And I say games in quotation marks. Really, I should call them cases. So we developed 7 cases across a range of different areas. So natural resource management, supply chain management, tourism, and so forth. All models were developed and tested in Stella Architect, bundled within a single UQ Cases app, and there was a reason why it was done that, and this was to do with a view to making them part of a summative assessment and putting them behind UQ firewalls and so forth. That was more to do with the IT people. Well, and we had a lot of fun developing these, and I think that's an important part. They were fun to make. Some of the common features. So when we developed this, we set this framework, we would typically show the model structure. And actually, I'll start with the second part. There are three core components. There's a story, and we always feel, and I think this is fairly widespread, that storytelling and a strong narrative is really important in system dynamics modeling. What is the story you're trying to tell? What is the story you're supplementing with your model? The model itself, so the model is this interactive tool that you can sort of engage or interact with the story, and then a quiz to provide a level of testing your understanding of the case itself. So these three components. The model structure is typically shown. So I've highlighted the top right one. This is actually our version of the bear game, but it's not bear, it's about kombucha. Okay, but you can see that the structure is shown on the model page, and quite often these cases, the structure is a means to tell the story. As the story is presented to the user, this model structure itself is shown. And each case has a UI panel, a user interface, where you can provide or change parameters. And this is very much a text entry approach. The Macquarie Island case, I would say this would be the #1 case that was developed. This is the very first case. And Macquarie Island is a very pivotal story that we use to provide entry point for teaching system dynamics at the University of Queensland, both in my course and also at executive education level. And this is about an island south of Australia that had a native seabird population, and the introduction of cats and rabbits, rats, mice, had a detrimental impact on the seabirds. The cats were killing a lot of seabirds. The Australian government removed the cats, and there was an unintended consequence that the rabbit population exploded, basically destroyed the habitat for the seabirds, which are land nesters, and so there was a worst impact. So you'd actually made the problem worse. It was a fix-it-fail type archetype. So this is a really important case. So we saw this as our pivotal one. A tourism town, this is an example. This is the one that I worked heavily on. It's probably the most sophisticated of our cases in terms of the size of the model and the breadth of the model. It's a derivative of the World Bank study I did in Indonesia and the Philippines. So a hello to anyone from the Philippines and Indonesia who might have dropped in to watch this, particularly if you were involved in the Seacrest study. And I've subsequently used this tourism town for summative assessment, and that required a little bit of strategy, how to go about it. Just to highlight again the general components, the standard components of this first generation. There is a story. We try to provide these bite-sized sort of statements that lead the user through the story using fairly plain English with a sort of an interesting story arc. We have the model output. I was very interested, so there was a fair amount of freedom on how we went about this. I was very interested in providing an isometric sort of Sim City style approach to tourism town. So when you run the model, the icons appear or disappear and the color changes to provide some sort of indication of what the situation is. You can also view output graphs, and there's a lot of output graphs for tourism town. The bottom right is an indicator of the user interface in terms of inputting data. So this is what I meant by text entry. We have these text fields. You can scroll through them, and there's a lot of things you can change. And there's a little information button associated with each to give you to tell you what it means. And then the quiz is located on the left-hand side. It's typically a 10-question quiz that you can use to sort of self-test your progression through the case itself. Again, as everything, we went in this with sort of quite confident and a bit of enthusiasm, maybe slightly misplaced. We use these cases in class with mixed success, and probably one of the telling parts was it wasn't always engaging or used in an engaging way. And so that was really this idea that if you build it, they will come. That was the mental model that we used, but we really needed to think about, well, why would they come and how will they use it? Accessibility issues was in terms of, because the cases were located within the UK cases apps, We had trouble trying to get students to access those cases, and it wasn't necessarily a technological issue. It was more of listening to what I'm telling you to do and not following the instructions, and that really disrupted the momentum of the class if I had to spend the first 30 minutes trying to get students to be able to open the cases. And I also feel that the cases themselves, probably with the exception of the Macquarie Island case, the one shown in the top middle, they weren't designed for a specific purpose. They're sort of a broad purpose type models. And I thought, oh yeah, lots of people could use these, but without that focus, it sort of diluted the effect of them. I would then say that the second generation was what was called the lobster game. So in 2021, there was a bit of money left over in the UQ Cases project, and so it was put to me, would you like to make another game or return the money? And I said I'd like to make another game. And I very much led the development of this one, again in association with BTM, with NENAD. So I was the one who developed the stock and flow model, and Stella, NENAD was the person who then transformed those models into Unity 3D. So what you see on the screen, and this is what he did for all the cases up to this stage. I started to focus in on a specific learning requirement, and that focus was that the students could use this case to reconstruct or reverse engineer the system structure given the evidence, which is the story and the graphs. So the graphs when they run the model. So working to the sort of first principles of systems modeling, that it's system structure that informs system behavior, but it might only be system behavior that you can see. And I really wanted to situate this in reality, which many of the UQ cases did already. And this is based on the Australian rock lobster fishery, which I thought was a really interesting story. And again, it comes back to what is the story you're trying to tell. I developed and tested the model in Stella Architect. Again, was what we did for the first generation games. Decided to drop the quiz component. This is one aspect I just didn't see was catching on in class. I wondered whether really, what was its role? How would we use these cases? So I thought it was fairly redundant. I looked at focusing on changing the user interface. So the bottom right-hand panel there on the very bottom, you can see controls. I started to use switches and sliders, and I started to remove some of the meaning in terms. So rather than saying, what does 0.235 meters per second mean? I started to put these sort of non-unit scaled interface elements, with the idea that sort of the focus is on that we know that one end is a low effect and the other end is a high effect. And the last part I thought was important is that we actually made it available to run through the browser. And that's the browser link there that you can access. If you were to type it in, you can run that. And that started to address the accessibility issues. So the students could immediately get into it and run the game. And so we don't lose that momentum of trying to sort that out. Problems. One student told me that the user interface is clunky, okay, or still clunky. So this is direct student feedback. I thought the motivation was good at times amongst the students, and motivation is a really important construct here in terms of learning, education, but there's always this challenge, well, how do we improve this? How do we elevate it? And even though it's called the lobster game, it's still not a game. And I think this is an important feature that's missing from the UQ cases. I think going from gamification to serious games is important. So this then leads to the final current generation, the third generation. Okay, and I'm going to this will be the ending point, but it'll take sort of 10, 15 minutes to end on it. This was where there's a heavier focus. So the philosophy was to say, okay, we really need to shift the focus to a more user-centered design. The previous cases, even though the focus was on the students and their use, it was very much still within, I would say, the domain of the modeler. We're still looking at it from our perspective and not from the end user perspective. Learning from the lobster game was the importance of using learning objectives or having a clear learning objective or objectives, and also applying constructs. So I've talked about motivation and fun several times. And then when you think about it, this is really what we're trying to do. We're trying to motivate the students to learn. Why would they use it? How do we get them to use it? How do we get them to enjoy using it, that they want to use it again and maybe tell others? And started to think more about the theory or theory-based design. So I've talked about this this issue or this element of self-determination theory and autonomy, and also the theory of flow. So self-determination theory very much talks to motivation, and motivation for learning, and the intrinsic and extrinsic factors. The theory of flow is very much about the enjoyment or the fun construct. So I started to look at the literature around that to help understand how might I design a better game. I also felt that I knew that I was working in the serious games and gamification space, but I didn't really have a clear understanding, well, what does it mean, or what is a unifying definition? And so the key unifying definition seems to be coming from determining it's the use of game design elements in a non-game context, which itself seems a fairly sort of broad statement. But I also do think it does highlight that what is the role of games and gamification, which leads to the next statement from determining, which I thought was more important. So this is not a direct quote, which is why it's just a sort of paraphrased. But there is a difference between serious games and gamification. They're both game-oriented, but they are separable by whether they are fully fledged games, which is a serious game, or whether they're just drawn upon design elements, game design elements, which is gamification. And I really wanted to focus on it being a fully fledged game. I thought that was the important pathway to motivation and fun. But then the final challenge is, well, if you make it too fun, are people actually learning? And if you make it all about learning, are they actually having fun? And so that's a sort of a bit of a tightrope that needs to be walked. And this is something that's very prevalent in the serious games and gamification literature. And there'll be those who say there's too much focus on learning, and those that say there's too much focus on fun. But it is a very much almost an experimental process. But I think providing a structured approach to developing the game will at least help to get that balance fairly close. In terms of the pedagogically driven design, I looked through a lot of literature, and there's a lot of literature, and this one from Catalano et al. Really resonated. I think it aligned with what I was starting to think anyway. So the key questions or the key sort of aspects are, situate the learning. How is the game or the model or the tool going to be used? So think very carefully about that. And I think that then aligns with the idea of, well, what is the learning objective? How are you going to deliver this? Even to the point of, is it going to be delivered online? Are you going to be in place? Is it going to be a large classroom? Is it going to be a tiered lecture theatre? So how do we situate the learning? A really big one is minimizing the cognitive load. Is the learning curve too steep? And I think this was one of the issues with our original cases, not so much in terms of what they look like, but the user interface. Even the second generation, there are a lot of options. So how do you decide what to do? Is it too overwhelming? It also comes back to this situating the learning. I'm very much of the mind that I want to run these games in a single classroom, probably within 60 to 90 minutes. So you don't want a steep learning curve. Engaging the learner constructively, is the interface appropriate? So the user interface is very important for very much, I guess, differentiating between whether the person is a modeler or whether the domain is a decision maker. And I feel that these models are about learning, but they're learning to make decisions. So I'd like to focus on the decision making. There's always place within a system dynamics course that you want to talk about the model, but a lot of the application is very much about, well, how do we use these decision support tools? I really think that the facilitating the learning task is an important aspect. Is a facilitator needed? It's not always needed. But in terms of how I situate it, I think the facilitator is really important. And this, again, aligns with that tradition in system dynamics and participatory modeling of the importance of having a facilitator. It also helps to minimize the cognitive load if most of that load is taken by the facilitator, and the facilitator can lead the end users through the process and provide them only with the information they need to know. And that provides a fantastic outcome, which I've seen. The last point that Catalano talks about is the flexibility, reusability, and exploitability. Where can it be used? Again, I mean, the original case studies were probably too rich, but there was this idea that, oh, these are great because they have so much richness, they can be used anywhere. So trying to get that balance right. Reusability is, I do look at how I could use some of these games outside of the classroom of teaching system dynamics. because I think for one thing, it's a way to teach systems dynamics to people who aren't doing system dynamics, and whether that's explicit or implicit, and that will really depend on how that is presented, and the flexibility. I guess that's another tightrope balancing act. You want to provide flexibility because flexibility also helps in terms of autonomy, but at the same time, you want to provide constraints and facilitate it. You want to minimize the cognitive load and keep it a sort of enjoyable experience. So that's an interesting one, particularly in terms of self-determination theory. So developing the third generation games, I've built these guiding design principles, which I am fairly satisfied with, but I will continue to refine them. Very much scaffolding the model upon learning objectives and constructs, as opposed to the earlier attempts where it was model first and learning objectives second. A clear objective to win. So this is the idea that there should be something you're trying to, maybe not win is the perfect word here, but although I think winning is a strong term, but making it a game, not just gamification, not making it have a few animations and sprites and a funky user interface, but having a purpose to try to achieve something. Simplifying the gameplay. So by this, I think I'd really focus on limiting the decisions that the person has to make. Again, this comes to not overly overloading the cognition, and more thoughtful UI, which I started to explore in the lobster game, but still made mistakes. One of the aspects I like about using software like Unity 3D, which is where we made the original cases, is that you can make dynamic user interface and you can sort of actively hide and show things that need to be hidden or shown. But in terms of where I'm going, which is the last point down the bottom of the MVP, is how do you then provide a thoughtful UI, given that you might not have that freedom that a software game engine like Unity 3D or Unreal or using Python would allow you. Very important to me that it's a multiplayer game, and the multiplayer is the bit that brings in that sort of participatory approach rather than being an isolated approach. And this also feeds into being facilitated gameplay. Run it as a game, but run it in a workshop where you control the game, but you show it on a big screen so everyone can look at the screen. Going back to the multiplayer, this round-based approach is really important. You're not just plugging and playing. You don't change the conditions, run the model like a scenario and see how did you go. The round-based approach is where you can stop and start the model and allow the people involved, the decision makers, the end users, to think about what was the outcome of their previous decisions, and because it's a multiplayer game, what was the outcome based on their decisions conditioned upon everyone else's decisions, and then come up with a new decision or revise your strategy. Incorporating tactile elements is really important, and they might be just a bit of paper that they write on. It's really important to have some sort of physical element, and then developing a minimal viable product. And this is very much the language of a business school. It's really important that, I feel anyway. So I got a bit distracted trying to produce the best game I could using Unity 3D, and I can code in Unity 3D, but it was a slow process. I was getting bogged down, and someone said to me, well, why don't you just create a minimum viable product? And that was a bit of an aha moment for me, particularly given I would say the flexibility. So I used Stella Architect, and so I created a MVP of a game using Stella Architect. And it took me about a week to create that first version from conceptualization through to full modeling. Okay, and that game is Sustainable Fish SD, and that's a screenshot from Stella Architect with the graphic itself generated in ChatGPT or DALL-E. The motivation for developing Sustainable Fish was to help teach concepts of Hardin's Tragedy of the Commons, but from the perspective of both sustainability and system archetypes. So it's a really useful thing to look at, because sustainability people are interested in Tragedy of the Commons, but in system dynamics, it's one of the system archetypes, and that's actually one of the modules we teach is system archetypes. And I've observed in class that the Tragedy of the Commons archetype seems to be the hardest for students to apply correctly. And I have a theory that it's because it's a mixture of systems-based and agent-based elements. It's not just a system dynamics model because you've got these agents interacting. You could say that the escalation system archetype is a similar thing, but an escalation generally happens at larger scale versus supermarkets versus countries, for example. But when we look at examples of tragedy of the commons, you're very much looking at individual actions and how the collective outcomes of those individual actions affect, say, a community because of a common pool resource. So I thought this was maybe a barrier to really understanding how the tragedy of the commons system archetype worked. So I had the aim of building a multiplayer game. So it was always going to be multiplayer and a game that provided a means of learning about the tragedy of the commons, incorporating or at least cognizant to the system perspective and the sustainability perspective, which I was teaching both at the same. Last year I was teaching both system dynamics and business sustainability, but I'm no longer teaching the sustainability one. The learning objectives, I came up with a few learning objectives to help clarify what is it I want them to learn from the game, which I won't dwell on the learning objectives at this stage, even though they are important. But what I thought was important was the design approach. And there are lots of different design frameworks for gamifications in serious games. And I split into a simulation component and a game component. The simulation component, I did a full system dynamics approach. I conceptualized it using a CLD. I understand the dynamics of fisheries pretty well. Okay, so it's got this element of fish catch with catch per unit effort, but I've also brought in an economic sub-model around price, supply, demand, and price, demand, and supply. And then the agent base, I was able to situate outside of the model and say, well, this is the player input. They are the agents for the game. And I used my sort of standard approach that the red are positive polarity and black is negative polarity. I created a stock and flow model. There's actually 5 subsections or submodels, but these are the 4 main ones. Okay, so help me to sort of clarify what are the subsystem components, and these are what they look like. And being an ecological modeler, I went full out testing it. What I really wanted it to do was to build in a tipping point so that the fishery would collapse. So I was basically set the model to fail. So this is what this is about, very much a sensitivity analysis. And then the game architecture I developed in Stella Architect interface, and using the interface tool within Stella Architect. I'm just mindful that I'm getting a bit close to the edge of time. So the story is presented in 10 pages. There are 9 pages here, again, following that very. So this is what I'd be showing as a facilitator up on the big screen and reading through it. Okay, sort of ending with the dominant statement or the challenge. Can you manage your fishing boat? So you've got different teams. These are the core screens. In terms of minimizing the decisions, I only ask one decision per round, and that is how much fishing effort will you apply per day from 0 to 24 hours. Each team discusses this, they give me a bit of paper, and then on the big screen, I move the slider, and I can sort of play with that, sort of how I do that to engage with the students to motivate them. So if one team makes a sort of an outrageous decision, I'll typically do theirs last, and I'll sort of do it slow and fast and try to play on the students and see them watching it. The bottom left is what we see during the gameplay. These are the rounds. You can see these vertical lines. And at the end, I can open up the page and say, this is how you went overall. Okay, so just reiterating, it's game-based, play to win, round-based. Tried to make it simple gameplay through facilitation and through making one decision. Multiplayer, although there is limited scalability. Using a big screen is important, so having a good room. Having effort cards, so I printed off some cards which are on the right. This is where they write their information. And creating a minimum viable product, so it's fully contained with Stella Architect. So I only show them the interface. I'm not showing the model. I used it in class this semester. I had 6 groups, with about 4 to 5 per group. So each group is a fishing boat. This is my group that's made up of business students and health and agribusiness and whatnot. And they decimated the fishery within 3 rounds. Okay, so they did a great job of completely annihilating it. But the narrative that was coming out while they were making the decision aligned with tragedy of the commons. So it was interesting to hear their comments that were being made. And then we reran the game, and I appointed one of the people in class to be the fleet captain, and he did a fantastic job of negotiating with all the groups to come up with a common approach for all the fishing boats. They were very cautious about their approach, and they managed the fishery in a much more sustainable way the second time round. I visited Stockholm University last month or the month before, wherever, recently, for the geography department. So I was talking to environmental science students who were doing system dynamics. We ran the same game, and they were much more cautious about their decisions, re the environmental outcomes, but they still heavily impacted the fishery. But the narrative that they were talking about when they were reflecting on the game was different. So when I played it in my group, they were saying things like, we need to get to the, we need to catch a fish before other people do. These group, they were saying things like, how could you sleep at night if we catch too many fish? And it was really interesting to hear. But this is the fish population, and they still made a good impact on the fish population. So this is the actual data from the Stockholm University game. Just to start to wind it up now, some key points, which I've already mentioned a lot of these: scaffolding on linear. If you were to build a gaming SD model using my approach, and there are different approaches, it's not saying there is just one way, but there are important questions to ask, like, who is it for? What do they need to see? I feel that the minimizing cognitive load is important, multiplayer is important, round base is important, okay, incorporation of physical objects is important. Large screens really works well, and I look towards the likes of En-ROADS and how well En-ROADS does in engaging. The group reflection is important. And then the whole package itself, you're trying to deliver an experience rather than deliver a model or a tool. I think that's sort of helps to distinguish between what's called a red ocean market, which is, I've got a tool, but everyone else has got a tool. It's just another model. But if you're trying to deliver an experience that's a less congested market, there's a lot of value creation to be had there. So that's called a blue ocean market. And this is the final slide. So I'll wrap up here now. But this is there are 3 cases that are available through this website. So you can, again, through the browser, you can access all 3 of these. You've got Tourism Town on the right, you've got the lobster game in the middle, and on the left is a coffee shop game that me and Nenad built up a year or so ago. I still haven't fully worked through how I'm going to use that one, but that was a bit of fun to play that one as well. Okay, so thank you very much.
Thank you, Russell, for that presentation. Feel free to ask questions in the questions box you have for him. I do just want to point out that this has been recorded and it will be published so people can review it again at a later date. It will be published on our faculty engagement page, and it will probably be available next week. So I just want to make sure that people are aware of that as well. So we do have some questions. So how would you apply SD models related to climate change in a small island, for example, Ambon Island?
How would I apply SD models to climate change?
To climate change in a small island.
To climate change. Okay, well, I guess my question would be, well, what is the actual question that you're trying to answer? What is it you're interested in? I'm interested in climate change modeling. I think there's different avenues. One would be, what is the impact on the environment, for example, such as sea level rise. And I know people have done, so Oz Sahin at Griffith University, he did an SD model for his PhD years ago that looked at stormwater inundation from sea level rise using a coupled spatial SD model. I would think it's, if you're looking at adaptation or you're looking at economic aspects, it's very important. What is the problem? I guess the problem articulation stage would be, how are you approaching this? Are you looking at the impacts? Are you looking at responses or mitigation? So that would be a very important part, is to say, okay, if I'm starting with this broad concept of climate change in a small island, what is it I really want? What is the actual problem? Is there data or evidence that we can look at? What is the dynamic behavior of the system? So starting to refine what is the actual issue. There's many things you could do. I mean, I recently worked on a PhD study with Arif Rahman, who's back in Indonesia now, looking at decarbonisation. So decarbonisation is a climate change, and Indonesia being an archipelago, but decarbonisation of the energy sector. And the way we were interested in government policy. It was very much a demand-driven system. You know, the consumers were driving the energy side in terms of what they wanted for their fuel. It was something that was impacted by government policy, which is subsidies. What we found really useful, and I find useful a lot of places to do with climate change, is to use a goal seek type framework to build it up. So frameworks are really important, so it doesn't become this unwieldy model. And goal seek saying there's a target, and a target might be zero emissions or it might be neutral emissions. And the nice thing I like about the goal seeker framework is that it can quite easily be extended to be an eroding goals archetype. And we're starting to see a lot of narrative about some of these goals that were quoted for 2030, such as the UN SDGs or the emission targets, are now being rescinded or changed, and that to me strikes of that's a really useful framework to use if you're looking at something of there's a target. If you're looking at impact, Carl Smith and I, when we worked in Seacrest in Indonesia, Philippines, we very much focus on a sort of a DIPSA, the driver pressure state impact response type framework. I think frameworks, so getting the question and articulating the question is important, or the problem, but also having a good structure in place to build your understanding of that system is also important. I don't know if I fully answered the question, but it was quite a broad question.
Thanks. We have another one. How are you teaching the concept of multiple models on a same topic can be shown, and are possible in parts defined by highlighting what is the purpose of the model being built?
Yeah, this is an interesting one. I've actually sort of had a bit of a change of philosophy. So I do show. What I'll do is I'll show models. You can when you present a model, you can present parts of the model and build that model, or you can start from, say, a subsystems approach and say these are the subdomains of the model, and talk about that and how it relates to the story. Then open those parts up and build those or unpack those models, and it can do that. And if you mean by different models within the same model or different types of models, I typically try to make them quite simple, regardless, because I've only got one semester to teach this concept, and it's only half the semester for the stock and flow models. But where I was starting my answer for that was that I've started to shift. I do think it's important that people know how to build models, but I feel it's more important that people understand how the models can be used, if that makes sense. I mean, it's really important that they know about building models, but I'm trying to shift the focus that, okay, you're trying to build a model, but the model is being built for a purpose. And so it's really much about, well, how can we use these models? What is the benefit? And to that end, I get people in to do guest lectures. I got this year we had Dr. Hussein Hussaini from University of Sydney presenting his model that he's been working on in terms of the health space. And these students really enjoyed, so he presented his model in different levels of sophistication, and his is a very sophisticated model, but he was also showing and focusing on the user interface and how important that is. And I think the ability to be able to articulate, what does the model look like? How's the model built? What are some of the best practices in building models are important. So I tried to focus on those, getting that sort of groundwork in place. I tried to present models that aren't too complicated, but we're trying to model complexity. We're not trying to develop complex models. So that's important. And then trying to say, well, why is it a useful model? We very much go back to that phrase from George Box that all models are wrong, but some are useful. So what we're trying to do is create a useful model. How do we know it's useful? We can sort of experience it. We can show how useful it is. We can make decisions with it.
Is it possible to get a copy of your games for use at our university? What is the process for making such a request?
So, okay, well, the UQ cases that are embedded within the UQ case app it's very much tied to the course. And by the course, you have to enroll in the course. So I would say they're not available. But the UQ cases ones that I have shown on screen at the moment are available, these 3 games. So these ones are available, you can access through that web link that I've got on the screen at the moment. The sustainable fish one, because we're still, and I say we, there is a few of us working on this, but I'm leading that. I would like to make that available, and I would just simply, on request, I would email it to you, but not at this stage. I would say early next year I can make it available, the entire package. I'm fairly happy to share this information. We're just doing some final testing. We've just had, what's exciting to me for the sustainable fish game is we've just had ethics clearance to run basically experiments with staff and students to test the impact of this game. So we very much focus on the design of the games, which is what I've presented, and now I actually want to test the impact. Are they achieving these learning objectives, or how well are they doing? And so I'd like to do some of that first, but I'm very happy to share this when I feel it's appropriate to release them. I'm also very happy to collaborate or to communicate on any ideas about games and provide my thoughts, because I've spent a bit of time thinking about this and I've made a few mistakes and fluff ups. That's fluff ups, I should say very clearly, as I've gone along. Okay, so but in terms of these games, these are available now. These three, the other UK cases, there is an idea. I'd like to make the other UK cases available through a browser, but that takes money and time to do that. So I'm not sure how many more. Macquarie Island would probably be one that I would like to do, but I'm actually in the process of a bit of a redux for Macquarie Island, because we found in class this year that it didn't really hit the nail. So we started to actually redesign Macquarie Island in class, and I use that for a bit of a thread for teaching the semester. And actually that's one aspect I haven't covered today. That the ability to have some sort of thread that takes you right through the semester is really important. And this semester we've used the idea that we're going to rejuvenate the Macquarie Island app, and I'll do the same sort of MVP approach using Stella Architect.
In the sustainable fish SD, are virtual fish populations considered isolated, or connectivity is incorporated in the models?
Yeah, well, it's an SD model, so it's just an homogeneous population. There is no connectivity. But what I'm interested in, so the idea with the minimal viable product, the SD model. So the SD suffix was an acknowledgement that it's a system dynamics model, and the next version would just be called sustainable fish. But I digress. I'm really interested in pursuing that sort of spatial element, and that spatial element becomes a bit easier to understand, or to implement, I should say, if you transfer it to say Unity 3D, which is very much an agent-based approach. I'm interested in being able to build the complexity of these models. So one thing would be having different communities of fish. At the moment, there's only a single community of fish. There is no location really. It's just that there are just fish. It's an homogeneous population. There's no size differentiation. There is a population model. So there is fish recruitment in terms of births, and there's fish deaths, and then there's fish removals from fishing. I'm interested in providing some sort of dynamic in terms of there are different locations for fish. I was interested, I guess, in terms of the fishery type or the fish ecology or spillover, but I was more interested in decision making if you were to have a population of fish close to shore or close to the docks, and another fish population much further away that potentially more lucrative, but there are sort of increased risk or vulnerabilities to go there. It takes a little bit longer, but the payoff might be higher. That's what I'll be interested in. But I am looking at building sophistication into these games that you can sort of gradually or incrementally increase. But at the moment, it's a very basic fishery model, and that very much sits with this minimum viable product approach that I've taken.
All right, we have time for one more question, and does this modeling analyze ecosystems at a local scale, and what would be a most reliable scale?
Oh, this is a tricky question. It doesn't, I guess it's how you situate it. They're quite generic models. So the lobster model is very much at a national, international scale. It represents, although it's not a simulacrum, it's a sort of it's a homage to the lobster fisheries, and it does use some of the dynamics and the interplay. So there's a supply chain, for example, and so that works at a national, international scale, which fits with the lobster model because it is a live lobster export market predominantly. So that's of interest. In terms of sustainable fish SD, because it's still at that minimum viable product, it's not really placed anywhere at this stage. And so there's an opportunity, there's two different ways. One is to model it, to make the model localized. And that could do with, having the data and setting the scale and setting, some of the actual quotas or requirements that are specific to a place. The other one is how you tell the story, how you present the story. So use a fairly generic model, but the story itself places it locally or not. So when I run the sustainable fish SD model, we're not saying you're not fishing in the local estuary in Queensland, or you're not fishing sort of near Stockholm, or where we've run these games. But the idea is that you are in a fishery. It's a shared resource fishery. The situation now, there are no regulations, there are no quotas, there are no discards. There are no rules, basically, which sort of fits with the tragedy of the commons. That's an open pool or open common pool resource, that can be exploited. But I think it comes back to the process again of developing. You just have to sort of think about, well, how do you situate it? How do we situate it? How are we going to use this game? Are we going to be, in terms of reusability or scalability, it's getting the story and the model integrated correctly. I hope that answers the question.
Excellent. Thank you so much for everyone for your questions, and thank you very much, Russell, for your presentation. We greatly appreciate it.
No problems. Thank you for inviting me.